Thank you, Heidi. So welcome everyone. My name is Lauren Powell, and I'm going to give you a talk today on a hands-on approach to cybersecurity education. So as part of the research I've done, we teach the cryptography and IT security module on the undergraduate computer science program. And that is led by my colleague, Dr. Philip James. Him, Dr. Liam O'Reilly and Professor Farron Muller have helped with this research. And I also teach the computer security program on the applied, or the module on the applied software engineering program on the degree apprenticeship. So from our sort of background in school education teaching, and a lot of this involves lots of hands-on activities to try and captivate the pupils, we wanted to bring this hands-on approach into the cybersecurity education and see whether we can relate that and make a more engaging experience on the degree course. So when we first started, a little bit of background information, we looked into actually what the computer science curriculum involves and what they were sort of looking for. So generally, it's a classic subject that's often delivered through lots of lectures and sort of handwritten theoretical exercises. And this is what the university undergraduate program involved. But when we were looking into industry, we found that they really wanted people to have this understanding of real system security and have this hands-on experience when they go into the security sector. And this is something that is not provided to students through these handwritten exercises. So we tend to find that universities take this approach due to sort of limited prior knowledge, also the time available. You don't necessarily have time to within the course to be able to give hours and hours of hand-on exercises. There's a lot of content you have to teach alongside it. Also, the campus equipment can limit you. There's lots of security policies. I'm sure all of you can imagine how when we wanted to propose this solution, which I will explain about later on, how the College of Science IT team really did not like the idea of having vulnerable machines running on the system. So this was a reason that sort of holds you back. And another reason is that it is only one course as part of a wider program. So you haven't got the resources or the time to make this feasible on a larger scale. So yeah, this course was previously taught with 2 lectures and a 1-hour handwritten lab. And it covered lots of different areas that we tend to see within the industry and that people within the security sector want students to learn about. So it covered many traditional topics such as cryptography, security threats and their causes, looking at penetration testing, looking at vulnerability and attacks, looking at issues within networks, looking at different tools and frameworks, and finally looking at blockchain technology. So the motivations behind this was to then find a practical aspect and provide these practical skills that are desirable for our students. And we worked alongside the Institute of Coding in Wales Industrial Advisory Panel they sort of help monitor and support the degree apprenticeship programme. And we worked alongside them, gaining their feedback to try and provide us with the motivation and aid us in finding really what we needed to do. And our aim is to provide students with to improve students' understanding of the course content by providing a hands-on practical experience. So there are a number of challenges we faced, which I've previously mentioned, but looking at them more specifically for this course. Firstly is the budget. We had a budget which was limited to approximately £5,000. So this restricted our possibility of having a completely virtualized environment, just because of the cost of different infrastructure needed to support the number of machines that we need for the number of students we have on the course. Also, the distribution of virtual images as well to students posed technical difficulties. So we couldn't do that on the existing university system because of actually being able to run these vulnerable machines, and this breached university policies. And then also this solution also restricts students to working on site as well. By having this environment that allows them to work on site, you're limiting them to go and develop their skills further and take it home. You know, not everyone will complete everything within a set lecture or a lab task. So we want something that's available for students to take away and work on offsite. So with all this together, what we proposed was using, instead of using virtual machines, was to use possibly their own machines, but we can't expect students to provide their own machines and have their own laptops and desktops that they can do this on. So to overcome these challenges, what we designed is a lab architecture that students could use within the university and be able to take home by having portable kits. So this is an example of a portable kit. Each student on the course is provided with a security kit, which contains a Raspberry Pi, and it's got a keyboard, a mouse, and a HDMI cable, and the cable to plug it in as well. And this kit then allows them to be able to complete all of the content. Each week then we designed a lab task, and we had the lab image put onto an SD card. So every week a student gets given an SD card, which they can put into the Pi and then run the machine then through the Pi to be able to do all of the tasks. So this was great because it means they could then do this within the university. We weren't necessarily running it on the current university machines, but they could also take it home to then continue the tasks at home and have a further play around with it. Wider part of this then is for each student then, if we're looking at it in terms of in the lab, each student had their security kit. So you can see 3 here. They could connect it up to a monitor, which already were in the labs. We also bought an SD card duplicator to then be able just to rewrite multiple SD cards at the same time. So when you've got classes up to 250 students, by having the SD card duplicator, that saves a lot of time and a lot of resources. We also purchased some additional equipment like wireless routers, vulnerable machines, additional vulnerable Pis and desktops and things, which could be deployed on the network. So by having a separate router and a separate network, we weren't then in breach of the university policy. So this solution overcame all of the previous challenges that I've mentioned. And we use this then to deliver our setup. So a typical task then, we sort of divided them into 3 categories of what the students are able to do. The first is individual non-network tasks. So this is where students are able to explore vulnerabilities in software which are locally installed. So the advantage of this is that it encourages students to play around with the software, have a go, they could do this on campus or at home. And it didn't matter if they broke anything. If anything went wrong, we can simply reflash the image to the SD card. If they corrupt the software or things like that. So it was great that there were, less boundaries for the students. They weren't worried about, causing any problems because it was an easy fix. The second task then, or category of tasks, is an individual network task. So this was running network scanning tools against other Pis and different things like that on a dedicated network without breaching the campus policies. And the lecturer then can set up the system by connecting additional Pis or PCs within the university room. So the limitations of this one is obviously the students can't necessarily complete this at home or offsite because they need access to the network. But it's something really simple of if students wanted to do it outside of lab time, it's quite easy to then dedicate some time just to set that up somewhere for them to have access to. The final category then is a group-based network task. So this is where students can gain and share data with other students. So something like encrypting data and sending it to another student using PGP is one of the lab tasks. And they can do this over a centralized network. And again, there's no restrictions with university policy about sharing this data. So there's a quick example here if you want to have a read of an individual task, just to give you an insight of one of the lab tasks and the lab content. So here you can see it's an individual networked lab task, which we use within the course. The students are able to explore network scanning using the Nmap tool. So we give them lots of information and help them with actually how to do that. And then they have a go at the task of being able to complete it and find out some information. So it's not a case of just using the tools, we're then trying to get them to apply it that bit further and find out, okay, there's this mmap tool, I can find out what's running on the network and what ports are open, what services are running, what versions maybe these are. But then they're using that as sort of an extra step to then explore the system and have a play around with other tools to gain the information needed to complete the task. So looking at the setup in practice, there are some requirements for setting up the labs. The first one is lecturer development time. There is an initial cost for actually producing this, so actually producing the images and making sure we've got all the kit and everything ready to go. But once we've chosen the desired OS and we've got all the software, the setup time actually reduces quite dramatically, because all you have to do is just reflash the images. Once everything's in place, it's quite simple then to run each following year. Secondly, then the students get to use actually using the setup. So we have maybe 1 or 2 labs available that we can do this. It's often the case that students have not used the system before and things like that. So actually getting used to it and getting set up can take some extra time. So sometimes you need like that half a lab of, you know, at the first hour or even half an hour for them to get used to it. Also the duplication of the SD cards, which I said about within the development time, that's something that by having the SD card duplicator is a really simple task. And finally, we do need some extra staff. Generally, we tend to have 1 lab tutor per 20 to 40 students. Sometimes students can work in pairs as well, just to be able to help them work through the task. You know, a lot of this is new content. A lot of it is, you know, using new systems that they've not used before. So having the extra staff available to help with this means we can support the students in the way we need to. But generally, this isn't any more staff than we would need for other lab tasks or other labs that we run as part of the degree program. So what does the lab provide then? The lab provides many different tools and techniques in each lab that students are learning about. They sort of learn about them in the lecture and then apply them in the lab that same week. So we're able to then actually replicate this, and they gain the in-hand experience and hands-on experience. There's minimal overhead for growth because of the SD card duplicator in the, I want to say 5 years now that this module has been running with the labs in this way. We have now massively grown our cohort size. So we have over 250 students on the module. And also it has the ability for the students to take the kit home and continue their learning and explore further than we are able to teach them. So one nice thing about this is that, you know, there's only so much content you can teach in 2 hours of lectures a week and in the entire module, and a lot of the security content that we teach in the modules is an insight to it. And it's, you know, not overly in depth. It's just sort of a beginners, because they've not done anything on cybersecurity before in the degree program. It's a real initial insight into cybersecurity. So by being able to apply it at a certain level, and then the students being able to take the kits home, they can continue their learning and develop these skills even further and have a go and play around with some of these things that we've taught them in a bigger context. So looking at then the student performance, there was a shift in the student achievement based around the change of the lab content. So you can see here that the first year that we taught it was in 2017 and 18, and you can see the increase and the percentage of students achieving below 50% had shrunk, whilst the percentage of students achieving 50% to 80% increased year on year. So by having this lab content, which all the students gain the practical experience from, they could then have a better understanding of the content taught in lectures. And having that better understanding, they were able to then apply it to the exam. So the exam was worth about 70% of the module, which is very similar to other modules taught in the program. But by having these sort of applied exam questions, we found that students had a better understanding and could better answer these applied questions. So it definitely helped with the students' learning experience further than just learning what they had in the lab. We gathered some student feedback then, and we found that since introducing the new lab, the majority of students' feedback has been positive. Students commented on how much they enjoyed taking the labs. They felt the labs were effective in helping them understand the course content, but they also found that it was really helpful to gain valuable experience. It was something new to a lot of students. They enjoyed that it was something different, and the fact that each lab then, each lab task sort of built upon what was being taught in the lectures. So they got to see the theory applied. In terms of lecturer experience then, for the team that are teaching this, we found that the introduction to the lab setup encouraged more discussion among the students. So because they were then applying things, they could then link back to it in further lectures and in further content. And they wanted to discuss around the field a lot more and not just about the topic covered. So they were trying to link topics together and sort of see how it related to something they'd done previously. So that was really great to see. The labs also provided real world examples, so students were more engaged with the topics. We observed that the students exhibited a deeper level of knowledge and understanding in their exam questions. And this then helped with the learning curve in the setup and deploying the labs. So taking this a bit further then, this worked really well in a university environment. And as I said at the start, a lot of us have experience in teaching in schools. And this is something I did in my previous role within Technicamps. And this is what I'm now working on next. So actually being able to deploy this similar idea in school education. So a lot of the school education, great, is still hands-on and it still follows this approach, but not in terms of cybersecurity. And it's something that's really hard, again, for schools to be able to run hands-on cybersecurity education because of the different policies within schools. So the idea is to run a capture the flag in a box workshop. So the idea is to then take the Raspberry Pis, so take 15 Raspberry Pis and a server to a school, and it's all in one box. So you just take one box to a school and deliver this content. The workshop would take a whole school day where students are able to learn about the content in the first few hours in the morning. And then we can run this capture the flag event in the afternoon. And the capture the flag event would be roughly like sort of 2 to 3 hours. And it's the sort of research behind this is to find out whether this is an effective form of secondary education. So looking at the capture the flag in a box, there's some sort of screenshots from the capture the flag game board. So hopefully you can see, hopefully this is big enough and you can see it. You've sort of got the idea where you have like a world map and you can select each country and each country would have a level on it. So we can vary the levels to different abilities. So you could have one task that, for example, is a cipher. So students would have to crack the cipher. We can teach them that in the morning about how to crack ciphers and then have some tasks in the afternoon. And depending on the ability of the students in the morning, we can actually toggle which tasks we put on. So I could put on some easy and some more difficult ones, depending on how the students coped with the content in the day. So it's great that it's variable throughout how the students are doing. So the students would click on a country and it would come up with a task. So this is an example of the task from the admin side. So it has a title and then it would have a description where they can complete some tasks. So something might be an example. So this one's great with a cipher where we have the idea of, setting the scene behind it. It's not just simply solve the cipher. They've sort of got to figure out what to do. So there's a note that has a code on it and you give them the code and they've got to then crack the code. So by decrypting the code here, which you can see there, it would give you the answer here, which is then the flag which they put in. And there are lots of hints and things. So if students aren't getting through it quite so quickly, they can click the hint button, get some extra hints. But overall, they then, for completing a level, they get the points. And based on these points, then it builds up, and it's quite a competitive way. They can work individually or in groups of 2s or 3s, and it's quite a nice competitive environment, but actually gaining this hands-on experience and using these tools that they wouldn't have previously used. Following this, then hopefully I'm hoping to complete a PhD. So that would be something that, using this experience of doing cybersecurity education at university level and then at school level, seeing whether maybe I could do a PhD on this further on. So yeah, thank you very much. If anyone has any questions, feel free to ask. Thank you.